Thanks for that introduction, and thank you all for coming to my presentation today. Today I'll be talking about the evaluation of fish passage via the Whoosh Innovations Fishway and their FishL recognition system installed at the Emiquon water control structure. First, I'd like to acknowledge my co-authors, Jim Lamer and Kara Phelps with the Natural History Survey, Janine, Bryan, and Nate Hamm with Whoosh Innovations, and Doug Blodgett with the Nature Conservancy, and Kevin Irons with the Illinois Department of Natural Resources. So our study site was at the water control structure of the Nature Conservancy's Emiquon Nature Preserve, which is located on the LaGrange Reach of the Illinois River, just upstream from Havana, Illinois. And the water control structure is indicated by the red dot on the maps on the right. The Emiquon water control structure consists of two culverts. The Fishway was installed on the south culvert. Stop logs were installed on the north culvert to store water pumped from Emiquon at a height great enough to create sufficient hydraulic head to move water through the system and down the steeppass fish ladder. A smaller number of stop logs were used on the south culvert to create a holding chamber for any fish that navigated through the system. Direction of water flow is shown by the blue arrows in the photo on the far right. Water from Emiquon flowed through the orange tubing and into the Fishway flow box, where the majority was directed down the fish ladder and into the spillway. A smaller stream of water was directed out the back of the Fishway to encourage fish movement into the false weir and out of the system into the holding chamber of the south culvert. The Fishway is comprised of three main components: the steeppass fish ladder, the flow box, and the false weir. Fish approach and ascend the steeppass fish ladder and enter the flow box. As mentioned previously, the flow box directs water down the steeppass to mimic the natural flow of water, while a smaller stream is directed out the back of the flow box into the false weir to encourage fish to continue moving upstream through the system. Fish exit through the false weir, which is the location of the FishL recognition scanner during 2021, and drop into the holding chamber. The FishL recognition scanner was unavailable in 2020. In its place, we installed two outdoor Y security cameras as indicated in the photo on the right. These recorded video 24/7 during system operation to track fish passage through the system. The objectives of our study were to evaluate native and non-native fish passage through the Fishway, with particular interest in whether invasive carps would be attracted to and use the Fishway. The secondary objective was to identify factors that influenced fish passage through the system. System setup between the 2 years was slightly different. In the fall of 2020, low water levels typical of that time of year meant the steeppass was installed resting on the bottom of the riverbed at a 10-degree slope. There's some evidence that fish may need a plunge pool beneath the fish ladder in order to gain enough momentum to launch themselves up the ladder. Therefore, in spring 2021, we aimed to elevate the system off the riverbed in hopes to facilitate greater fish passage through that system. In addition, the FishL recognition system was installed at the location indicated in the diagram on the right. In the spring 2021 trials, the system was elevated approximately 18 to 24 inches off the riverbed, with the steeppass being installed at a 14-degree slope. The red horizontal lines drawn in the above photos give some indication of the difference in the elevation of the system between the 2 years. In 2020, we had two YSI XO2 sondes that collected continuous water quality parameters during operation at two locations, one within Emiquon itself, and the other in the spillway near the steeppass outflow. These recorded dissolved oxygen conductivity, temperature, and turbidity, with the unit in the spillway also recording chlorophyll A concentrations. In 2021, only one sonde was deployed within the spillway, and it did not have the chlorophyll A sensor. Zooplankton collections were also made before, during, and after trials in Emiquon and the spillway locations to assess the input of a food resource as an attractant to fish using the Fishway. And details of those zooplankton collections are covered in Kara Phelps' talk later in the session. The focus of this talk will be on fish passage as recorded by the WISE security cameras in 2020 and the FishL recognition scanner in 2021. Using the WISE security cameras in 2020, film footage was archived and analyzed manually to identify fish passage. In 2021, with the FishL recognition scanner, images and measurements of individual fish taken by the scanner were saved to a Dropbox folder via an on-site computer and analyzed remotely for manual ID by Whoosh Innovations staff. This plot shows fish passage and some associated water quality parameters from the spillway SON during the 2020 trial. Time is along the x-axis with alternative shaded regions signifying 12-hour cycles from 0600 to 1800, 1800 to 0600 to visualize the day-night cycles of the trial period. The dotted line on the left indicates the time pumps were turned on and water began flowing through the system, while the dotted line on the right indicates the time pumps were turned off and the system stopped operation. Timing of fish passages as recorded by the WISE cameras is in the top panel. In the bottom three plots, we can see the effects of food-rich Emiquon water as it enters the spillway. The histogram on the right represents all the fish collected from the holding chamber following the trial. Fish ranged in size from 50 millimeters, represented by bluegill, which is confirmed by the WISE footage, and up to approximately 600 millimeters, represented by common carp. The majority of fish that used the system were gizzard shad. A total of 77 fish representing 7 species were collected from the holding area following this trial. Of these 77 fish, only 30 were detected by viewing the recorded WISE security camera footage. This plot shows the results of 6 trials conducted in the spring of 2021. Along the x-axis is the date. Alternative light shaded regions again represent those 12-hour intervals to signify day-night cycles. And the darker shaded regions in each panel represents periods of fishway operation. The bottom panel is main channel water temperature taken from USGS gauges at Florence and Henry Lock and Dams. The solid black line is an average of temperatures recorded at the 2 stations, with the gray region around the line representing the minimum and max recordings. The orange dashed line represents the minimum spawning temperature of 16 degrees, which is recorded in literature for gizzard shad. The middle panel is river gauge data taken from the U.S. Army Corps Engineers River Gauge in Havana, Illinois. The dashed blue line represents the stage of optimum operation for the fishway. In other words, the stage at which the end of the steep pass is exposed enough to create a sound of flowing water that may attract fish to the area. The red dashed line represents the maximum operational stage before the system must be turned off and the FishL recognition scanner removed to prevent damage to the electronics. The top panel represents fish passage by species as detected by the FishL scanner. For gizzard shad, which are represented by black dots, points were made more transparent, so overlapping points would create a darker region and thus signify greater fish passage. We had multiple instances of invasive carp passage, the majority being grass carp, which is shaded, represented by the shaded red triangle, with a single passage of silver carp, which is represented by open red triangles. We also had a northern water snake and a mouse and a vole move through the scanner while the fishway system was not operating. The stacked histogram shows the combined fish passage results of 2020 represented in blue and 2021 represented in red, with sample sizes of each species in the right panel. In all 2021 trials combined, we saw a total of almost 1,900 fish that crossed through the system, with the vast majority being gizzard shad, similar to that 2020 trial. 2021 also saw larger individual fish pass through the system, for example, grass carp up to 900 millimeters in total length, which may support our previous hypothesis of fish needing a plunge pool to ascend the steep pass. Some observations of factors that influence fish passage include increasing water temps. We had limited fish passage until water temps reached that 16-degree minimum temperature for gizzard shad spawning. Most large passage events occurred during a rising hydrograph, though this may be an artifact of the timing of our trials to take advantage of these events. Most passage also occurred in the evening and overnight hours. Input of plankton-rich waters did appear to influence the fish community present in the spillway. Electrofishing surveys conducted during Fishway operation yielded a greater number of planktivorous fishes, for example, gizzard shad, bigmouth buffalo, paddlefish, big-headed carps, etc., than similar surveys conducted during non-operational periods. Our original hypothesis was that big-headed carps would be attracted to the sound of rushing water from the fishway, coupled with a rising hydrograph as a trigger for spawning behavior. Big-headed carps are lobic and pelagic spawners requiring flowing water for egg development. Gizzard shad, however, spawn in lentic conditions with adhesive eggs that attach to littoral zone vegetation. A subset of gizzard shad in 2021 were collected and gonadosomatic index calculated to assess reproductive status. It's just shown here on the left. A comparison of relative weights between fall 2020 and spring 2021 of collected gizzard shad showed a significantly higher relative weight of those in 2021, which may suggest a greater spawning condition in the 2021 spring collected fish. More work is needed to determine what influences native and non-native fish use of the steeppass. A total of 10 fish species were collected between the fall of 2020 and spring of 2021, though the bulk was gizzard shad. It is possible that pheromones from spawning gizzard shad within Emiquon or phytochemicals from the Emiquon aquatic vegetation served as an attractant in the water that was pumped into the river and encouraged gizzard shad to ascend the fishway. Investigating other attractants, for example, shade or species-specific pheromones, may help determine what encourages fish use of the fishway. In addition, our trials demonstrated the difficulties of operating a fixed elevation system, especially with the wicket-style dams on the LaGrange reach of the Illinois River. This hydrograph shows the optimum operational stage, which is the bottom dotted line, and the maximum operational stage, represented by the top dotted line, with the trial periods indicated by black bars along the top. With the current setup, the optimal river stage of 8 feet was hard to maintain, particularly during the variability of the spring precipitation and flooding events. The images on the right show an 8-day difference between optimum conditions on top and flooded conditions on bottom during spring 2021. In addition to the steep pass fish ladder being nearly submerged, more of the floodplain around the water control structure is submerged, increasing the area in which fish have to spread out and decreasing their potential of encountering the fishway. In conclusion, though we had limited success in passing the fish species of interest, like invasive carps, we proved the utility of the system for passing other species, particularly gizzard shad. In addition, using the FishL recognition system demonstrated the capability and utility of an automated fish detection system for recording fish passage with high-quality photos capable of identifying various fish species and automating morphometric measurements of the individual fish using the system. For more info on the Fishway and FishL recognition system, I've provided links to the Whoosh Innovations homepage above, including a YouTube video of the Fishway in action and how they hope their system can be used in the fight against invasive carps. This project was a collaborative effort with much of the day-to-day operations being managed by our graduate student and co-author Kara Phelps, with the help of seasonal technicians at IRBS, and funding was provided through the Illinois Department of Natural Resources. And with that, I'll be happy to take any questions.